Assalamualaikum, my name is Rabiatul Humaira binti Muhammad Azmi. Today I'm with my classmate Nur Syahinda and Tengku Anis Patricia. All three of us are from Faculty of Applied Science, and we're going to talk about differentiation. First is the meaning of differentiation. Differentiation is a process of finding the derivative of a function. This method is used to determine how a function changes as its input changes. This gives the instantaneous rate of change, and it takes the slope of tangent line to the curve at any point. There are techniques of differentiation. First is power rule, constant rule, constant multiple rule, product rule, sum and difference rule, quotient rule, derivative of trigonometric function, and derivative of exponential function.
Hi everyone, my name is Nur Syahinda binti Muhammad Syam from AS120C. So right now I am presenting to you guys how to solve for question number 2. Okay, so let's get started. Find dy over dx for the following function. So right here we have this following function, 2x cosec x squared minus 1. So let's get into it. Okay, so let a equal to 2x cosec x squared minus 1. So we just write down, okay, this following function right here. Okay, so let a, okay, as let a. Okay, so we are going to differentiate this using product rule. Okay, so why we use product rule is because, okay, there is two functions that are multiplied together, where 2x is the first function and cosec x squared minus 1 is the second function. Okay, so differentiate a prime equal to uv. Okay, so I just write down, okay, the product rule formula, that is vu prime plus with uv prime. Okay, so we just list down, okay, u and v. Okay, so our u right here is 2x and our v right here is cosec x squared minus 1. So we differentiate 2x, we will get 2. And differentiate cosec x squared minus 1, we are going to use triple rule. Why triple rule? Because there is cosec. Cosec is a triple function. So, okay, triple rule is formula multiplied with differentiate angle. So, the formula for cosec, okay, is negative cosec x and cot x. Okay, so we just copy back. Okay, so we have negative cosec x squared minus 1, cot x minus 1, and lastly we are going to differentiate angle. Okay, so we differentiate angle right here, we will get 2x. Okay, so now we are going to substitute u and v into the formula. Okay, so our u right here, okay, we're just going to substitute this vu prime plus uv prime into the formula. Okay, so 2 cosec x squared minus 1 plus with 2x minus negative 2x cosec and x squared minus 1 cot x squared minus 1. Okay, so but this one I've already rearranged. Okay, so the next step is simplifying. Okay, we are going to simplify this equation. Okay, so as you can see right here, okay, I've already simplified this. Okay, so we will get dy over dx is equal to 2 cosec x squared minus 1 minus 4x squared cosec x squared minus 1 and cot x squared minus 1. Okay, so okay, but this also we already considered as answer, but okay, if you want to factor out this is also correct. Okay, but for me I am going to factoring this out. Okay, so factoring out 2 cosec x squared minus 1. Okay, so we get dy over dx. Okay, we must write dy over dx as subject. Okay, because the question asks us to find dy over dx. Okay, so we factoring out 2 cosec x squared minus 1, we will get 2 cosec x squared minus 1. Okay, and 1, okay, minus 2x cot x squared minus 1. So that is the final answer for this question.
Hi, my name is Tengku Anis Patricia binti Tengku Aswadi, and my student card number is 2024213344, and I will be solving question 2b, which is y equal to 2x minus 1 over time x. Since in this question we have one function divided by another, so we will use quotient rule, which is dy over dx equal to v multiplied by du over dx minus u multiplied by dv over dx over v to the power of 2. Then we will take u equal to 2x minus 1 and v equal to tan x. Then we have to differentiate both parts, which is if we differentiate du over dx, we will get 2, which is 2x minus 1. If we differentiate, we will get 2, and dv over dx, if we differentiate v, which is tan x, we will get sec to the power of 2x. Then we will apply the quotient rule, which is we will get dy over dx equal to tan x to the power of 2 minus 2x minus 1. In bracket, we put sec to the power of 2x. Then we will divide it by tan to the power of 2x. When we solve it, we will get dy over dx equal to 2 tan x minus 2 in bracket 2x minus 1 sec to the power of 2x over tan to the power of 2x.
Let's solve for the question number 3. Question number 3. Let's read this question first, okay? Given y square ln 2x minus with e to the power 3x minus 1 minus cot 2y equal to 2. So, find dy over dx using implicit differentiation. The first step right here, we have to separate this into each term. So the first term right here, okay, we label as A. The second term right here, we label as B. The third term right here, we label as C. And the fourth term, we label as D. So let A equal to y squared ln 2x. We are going to differentiate this using product rule. As I said before, why we use product rule is actually because there is two functions that are multiplied together. Okay, so our first function is y squared, and the second function in ln 2x. Okay, so we just list down, okay, u and v. So our u right here is y squared and our v right here is ln 2x. So we just substitute into this formula using vu prime plus uv prime. So our u is y squared, so we differentiate y squared, we will get 2y dy over dx. Our v is ln 2x and we differentiate ln 2x. Using log rule, we will get 1 over s. So we just substitute back into the formula vu prime plus uv prime. We will get ln 2x multiplied with 2y dy over dx plus with y squared multiplied with 1 over s. So that is how we differentiate using product rule for the first term. So now let's solve for the second term. Let b, we write down as let b equal to y negative e to the power 3x minus 1. So we are going to differentiate this using exponential rule. So exponential rule formula is copy all of these and multiply with differentiate power. So let b prime, we copy back all of these and we get negative e to the power 3x minus 1 multiply with, okay, 3. Okay, we differentiate power, we will get 3. So that is the final answer for B. Okay, so let's see. Let's see equal to negative cot 2y. So as we know that cot is trigger function, so we are going to differentiate using trigger rule. So trigger rule is a formula multiply with differentiate angle. So let's see prime. So this is trigger formula. Okay, so the formula for cot is sec. Okay, so negative, okay, so negative cosec square 2y multiply 2 dy over dx. We differentiate angle 2y, we will get 2 dy over dx. Okay, so negative we cancel out, we will get positive. So 2 cosec square 2y multiply with dy over dx. So from y square ln 2x minus with e to the power 3x minus 1 minus with cot 2y equal to 2. So we have already differentiated implicitly with respect to x. So we get the answer 2y dy over dx ln 2x plus with y square over x, okay, and minus with 3x to the power 3x minus with 3e to the power 3x minus 1 plus with 2 cosec square 2y dy over dx is equal to 0. So separating terms, now we have to separating terms containing dy over dx and term not containing dy over dx. So, okay, so for the left hand side is the terms that contain dy over dx, and the right side is the terms that do not containing dy over dx. After we separating terms, we are going to factorize dy over dx. So we have dy over dx 2y ln 2x plus with 2 cos x squared 2y equal to 3e to the power 3x minus 1 minus with y squared over x. So we have to write dy over dx as subject. Dy over dx equal to 3e to the power 3x minus 1 minus with y squared over x and over 2y ln 2x plus with 2 cos x squared 2y. So that is the final answer for question number 3. I hope this will help you guys to solve this question.
Now we will move on to the question 4, which is linear approximation. In this question, we will use linear approximation to estimate this expression, which is 4 root 5099 minus 4 over square root 5099. Then I will define the function with fx equal to x to the power of 1 over 4 minus 4x to the power of negative 1 over 2. Then I will choose the base point, which is, since 5099 is close to 16 and 16 is easier to work with, so we will let a equal to 16. Then I will evaluate the f16 equal to 16 to the power 1 over 4 minus 4 to the power over square root 16, and when we solve it, we will get 2 minus 1 equal to 1. Then I will differentiate using power rule, which is d over dx bracket x to the power of n equal to n x to the power of n negative minus 1. So I will differentiate it. D, we will get d over dx, x to the power 1 over 4, we will get 1 over 4x to the power of negative 3 over 4. And when the other one, we will differentiate d over dx in bracket negative 4x to the power of negative half, we will get 2x to the power of negative 3 over 2. So we will get f prime x equal to 1 over 4x to the power of negative 3 over 4 plus 2x to the power of negative 3 over 2. Then we will evaluate the f prime 16. So we will get 16 to the power of negative 3 over 4 equal to 1 over 8. Then we will solve it. We will get 1 over 4 multiplied by 1 over 8 equal to 1 over 32. And the other one, we will do 16 to the power of negative 3 over 2 equal to negative 64. So we will solve it with 2 multiplied by 1 over 64, and we will get 1 over 32. So our f prime 16 will get 1 over 32 plus 1 over 32, and when we simplify it, we will get 1 over 60. Then we will use the linear approximation formula, which is fx approximate to fe plus f prime a to the bracket x minus e. Then we will substitute, which in bracket 5099 approximate to 1 plus 1 over 16 in bracket 5099 minus 16, and we will get 1 minus 0.000625, and we will get the answer is 0.999375. Since we want it in 3 decimal places, the final answer we will get is 0.9999. So that is the final answer. So that is all from us. Thank you.